Hello, welcome to Technical Founders. My name is Carlos Lara, AI Technical Founder, and this video is an introduction to machine learning. Now, we've all heard of artificial intelligence, AI, machine learning, but what is it? In very simple terms, machine learning is using data to answer questions. So these will, in the simplest cases, it would typically be questions that we have as humans no trouble in answering. So for example, in our case here in this video, we will use the example of classifying incoming emails as either spam or not spam. And again, this would be something that we would just do manually. If an email comes in, we might just mark it as spam and it will go into the spam folder or not, and it won't, just based on, for example, the title of the email. And that's what we will use in this video. That's the main feature of an email that we will use, will be the title of the email. And again, and the purpose of machine learning really is to automate some kind of a task, which will help us or help a business or something like that. So add some real value there. So what are some of the prerequisites that you need for machine learning? And the first one is Python programming. The main programming language used in AI and machine learning and deep learning is Python. Now, you can also use C++ later, but to get started initially, you can get very far with Python. So that's the first. The second is linear algebra. Now, the way we deal with data, the way we handle data and process it in machine learning with AI is in the form of vectors. And functions are usually matrices. So obviously having an understanding of vectors, matrices, vector spaces, how to do operations with them is very important and very critical here. And if you know linear algebra, you have a big head start here. And the other is calculus. Now, when you're training a machine learning model, when it's learning from data, it's behind the scenes, it's really calculus what's going on. Some loss function is being minimized. So again, knowing calculus is very important. And I highly recommend the YouTube channel 3 Blue 1 Brown, where these concepts are explained really well and visually. So let's get started. Introduction to machine learning. Now, there are 7 steps to machine learning. The first step is to gather data. Now, in our case, we're going to classify our emails as spam or not spam. So we're going to gather our emails. And now the second step is prepare the data. Now, just the emails by themselves, and who knows in what format, it may not be ready to be processed by our machine learning model, our machine learning algorithm. So we can prepare the data, use typically Python code to process it and put it in a form that's ready to be used by our model to learn from. And we may also do some visualizations of our data. So for example, in our case of email classification, we might draw some kind of plot here. And then we can, for example, classify, let's say we do circles here to indicate that this particular email was classified as spam. And then we'll do X's to indicate that it was classified as not spam. So this is our data. And now we want to find the third step is to choose a model. So and a model is a function. So we want to find a mathematical function that will split that data. And let's say a line. And on one side of the line, if the point is there, that's spam. And on the other side, it's not spam. So choosing a model is typically an iterative approach. You might have to try different models and see which one gives you the best accuracy. But here, just from looking at your data, you can get a clue on what model to use. So here, just looking at the data, we can draw like a line, like a straight line that separates the data. And here from math, we know that this function is y equals wx plus b. We would typically call it y equals mx plus b, but w is because we're in machine learning. We call the slope of the line here, we call it w for weight. And this is just in a simple one-dimensional example, but in practice, we might have many different features because here x, right here, is our feature for the email. In this case, the title of the email, the subject title of the email. Y is our label. The label is the answer to our question. So 0 if it's spam and 1 if it's not spam. Or vice versa, depends on how you define it. But here will be 0 or 1, the answer to our question. The label, typically that's what it will be. I mean, in this case, it's going to be spam if it's on one side of the line and spam if it's on the other side. So we have our function here. So the weight here is the slope of the line, and it's something that you can adjust. And B will be the y-intercept of the line. So where it is, where the line starts, and you can also change that. You can change the slope, and you can change the y-intercept. So you chose your model. Now it's time to train it. So you prepare your data. You have all of your emails in a certain format, and now you want to train your model. You want to adjust this line y equals wx plus b, and initially it might not be like that. Initially it might be like that. So it may not be the best. It may not be optimized to give you the best accuracy. So typically we will separate our training data, our data into training data and test data. The training data is typically 80% that will be used to train our model. And then for the next step, evaluation, when we test our model, we use the other 20%, the test data. And you don't want to evaluate your model tested on the training data because it will have memorized it and it's going to be heavily biased. So it's not going to be accurate and representative of its predictive power. Therefore, we're going to use data that is never seen before. And that's what we would want in the real world. We want, whenever a new email comes in that the model has never seen before, we want it to accurately classify it as spam or not spam. So we train. We go through to a training set, and it's going to classify the data, and then it's going to look at the actual results. At the actual results. So whether that email those emails that I try to classify, whether they actually were spam or not spam prior, because it's labeled data. The answer was given to us with the data beforehand. And of course, initially, we don't know how that model may be because it's not optimized. The line might be like that. So obviously, initially, it does a very poor job. And then it does some calculus behind the scenes to minimize those errors. And then it's going to go through these training cycles and get better and better. So what's really happened, and this brings us to the next step, hyperparameter tuning. So you can look at the results of the training of evaluation and say, well, I don't like this accuracy. I want to do a little bit better than that. So what you can do is tune your parameters. So your parameters here are W and B. So B, again, the y-intercept, and W, the slope of the line. And as you can see, so the slope, you can change the slope of the line, and you can change the y-intercept, and those are your parameters, W and B, things that you can tweak to improve the accuracy of your model. And we call it hyperparameter tuning because after you've tuned those parameters, now they're hyperparameters because they have been tuned now. So as you can see, if the line starts like that, and you can first of all change the slope. So you can change the slope like this. So lower the slope. And you can get it there, and now you can change the y-intercept. So B, you can move it, and then when it's fully optimized, you end up with a line that is like that. That's going through separating those points cleanly or as cleanly as possible. And one side is spam, and the other side is not spam. So just in a very simple terms, just very high level, this is how a machine learning model trains with data, evaluates, and then tunes parameters using calculus behind the scenes to get to the optimal decision boundary, the line that will separate that data for the correct classification. And then the last step is a prediction. So you give your model, now that it's trained, you give your model an email that it's never seen before. And then it will classify it, and based whenever you evaluate it, you have a certain accuracy. I mean, this could be over 90% accuracy, so it will usually classify, and then you can make a prediction. Now you get an email, and then you can predict whether it's spam or not spam, and you don't do this yourself. This is a machine learning model, a machine learning algorithm that's been trained and optimized to do it by itself. So that's been automated. So it's pretty cool stuff. So in the following videos, we'll get into specific examples of specific machine learning models or machine learning algorithms and examine the differences between them, the different parameters that they have, and so on. So thank you for watching. If you have any questions, thoughts, comment below, and I will see you next time.